questions from the previous sample papers. And we're currently doing number 1.
We're going to find the average power that is absorbed by the 2 ohm resistor.
And the 2 ohm resistor is over here on the left side. We can bring everything that's on the right side to the left. Something to remember is the dots are on this side. So when bringing over the source, we'll reverse its sign. I'm always more comfortable with using voltage sources. So I'm going to turn this into a voltage source without much effort. That's 1. And I'm going to now let's move all the sources over. The left side remains the same. You will have, we'll multiply by 2, right to left. We have 2J two times J1 plus 2J, and this is reversed. So you either reverse the polarity of the source and write the same value of the source, or write minus in front of the source's value and keep the polarity the same. N is half. Oh, right. This is squared. N squared. The way I'm what? What I try to remember is you multiply by the number on the side that you're going to. So when you're going to the left, right, sheet. I think my meeting disappeared too. Okay. So this is multiplied. When I'm going from right to left, the number on the left, that's what I use to transfer all the things on the right. Does that make sense? So when you're going from right to left, you would multiply all the resistive or impedance elements with 2 squared. So that's the number on the left. And the voltage source by 2. On the previous page, we're going from left to right, so we multiply by square root of 2 squared, because that's the number on the right. And if you had to transfer from right to left, the number on the left is not 1, but you have to move the square root of 2 under 1. So that would be 1 over square root. So what you can do for this, always write it in the form 1 to n. You have 1 on one side and n on the other. And it n's on the right side and you're going right, you multiply by n, or n squared. And if n is on the right side and you're going left, you do 1 over n. If it's on the right side and you're going to the left, you change this over. You get 1 over n on the left side and 1 on the right. You're dividing both sides by n. And we're moving from right to left, you multiply by 1 over n. That's the number on the left. So that's strange mnemonic. So we have 4J and J2. To find the power through the resistor, we have to find current through it. To find the current, we can do a KVL. So the KVL in this way, that gives us -10, 0, I 2K I 10 J 0 2 5 amps, RMS. You have to find average power. That I think so. Should be right. Yeah. Voltage and current. Does it make sense? The average power formula is average power. I think it's V times R. V across the element times R. V times I to the element. That should be the average power.
So just to recap, so what we have done so far, for those who missed the first part of the session. From spring 2009 we had this circuit. This is not a transformer, it's just mutual inductance. So what we did first was find out the mutual inductance. This voltage source or dependent voltage source comes from the inductance of 2 on 1. So I2 is going through, when going through the dot, it's positive here. So the positive transfers over to 1. So the plus sign is on top. For this dependent source, I1 is going through the dot over here. The plus transfers over to the bottom. So the plus is at the bottom. And what we did was we wrote a KVL on the left side of the circuit. Since the question asked us to find I0, which is I2 and I0 are the same, we wrote I2 in terms of we wrote I1 in terms of I2 over here. This is simple algebra. And then we did a KVL on the right side and plugged in I1 equals this into that equation to get this. Now the answer might not be correct, but the process is correct. We didn't check the answer. Next we have a transformer question. This time the dots are on the same side, so there's no change of direction of current source. We transferred the current source into the voltage source because that's what I'm more comfortable with. Then we transferred the entire left half of the circuit to the right. So we multiplied by square root of 2 with the impedance and multiplied by square root of 2 with the voltage source. Then we first found the V open circuit. So if you open circuit this part, there's no current going through, so there's no voltage drop. So the voltage across at this point is the same as the voltage over here. So that's V open circuit. And when you short circuit it, you just divide this voltage across the entire thing to get the short circuit current. That's what we found over here. Z Thevenin. We found Z Thevenin, VOC over ISC. These cancel, so that's the Z Thevenin. We were asked to find Z for maximum power transfer. So Z would be equal to the conjugate of Z Thevenin. That's what we wrote. We just changed the sign over here. Then we were asked to find the voltage across that Z. So we plugged that Z in to the Thevenin's equivalent circuit. And then we did a voltage division. So Z goes on top, total impedance goes on bottom, times the voltage source. So we get this. Next we did this, where the recording started. I think we have enough time to start one more.
So for this circuit, you have to find I1, V1, I2, and V2. So we can see the relationship exists that V2 equals to N2 V1, I2 equals to 1 over 2 I1. So this is what you have to keep in mind. And once you keep it separate, because you'll have to come back to this for the process we're going to use. What we're going to do is transfer all the elements that are on the left side to the right side. You can do the other way as well. What I'm going to do is, what I like to do is change this guy to a voltage source. That's going to give us, I forgot to go. 2j times minus j plus 8j. You have the capacitor here. Once you do that, the rest of the circuit remains the same. And when you move this side over to that side, you replace this part with the circuit elements over here and multiply the voltage source with 2. That's going to give you 16 times 0. I2 will remain the same. Next, all you have to do is find, once you find I2, you will find I1 using this equation. For V2, you have to notice that you have the new circuit. It looks something like this. Signs remain the same because the dots are on the same side. This is the left-hand circuit. And this is the right-hand circuit. These are the equivalent impedances. You have the voltage source over here. I1 should be relatively easy to find once you do KVL. But for V, this is I2. I2 should be easy to find. For V2 is over here. So you have to do a KVL from this point and up to this point to find I2 or V2. That will give you this is x, y, minus x plus 2y plus 0. And you solve for V2 to find the value. Once you find I2 and V2, go back to the equations over here and use these to find V1 and L1. Let's start with this problem first and move on to the other one. And that ends the session. Any questions? All right. Thank you very much for coming.